Hello guys, so in this video we are going to study one of the major application of the adsorption process, and that is the process called as catalysis. Of course, first knowing what do you mean by catalysis, first and the foremost thing as we know that what do you mean by catalyst? Yes, so of course we know what catalysts are the chemical substances. Or simply we can say they are the substances which accelerate. So first part, what is that? Which accelerate. That means what? Increases, alva, which accelerate what? The rate of the reaction. As we have seen this in our chemical kinetics. How does it do this? Which accelerate the rate of the reaction? By decreasing the magnitude of your activation energy. Good. The second point, what is that? In order to say a substance is acting as a catalyst, it remains chemically and quantitatively, alva, chemically and quantitatively, you can also use it, remains qualitative and quantitatively unchanged when? After the reaction also. After the reaction. One more important point is that to say that a substance is undergoing or it is taken as a catalyst. What is that? Yes, it has to be regained. It has to be regained at the end of the reaction. It has to be regained at the end of the reaction. Alva. Then only we can say that a substance is acting as a catalyst if it is obeying all these 3 points. So whenever such a reaction in which you are using a catalyst and catalyst is performing all these points, the overall process is called as catalysis. This is important. Yes. So the substance which accelerate the rate of a chemical reaction and remain chemically and quantitatively unchanged after the reaction, yes, are known as a catalyst, and the phenomenon is called as catalysis. Yeah. So basically these catalysis is further classified into 2 types. Very much important. One is called as homogeneous catalysis, and another is called as heterogeneous catalysis. An important 2 categories you have to remember throughout your life because it is not going to change anywhere. Yes, so there are 2 types of a catalysis. Let us first understand what do you mean by this homogeneous catalysis. Remember, when the reactants and catalyst used are in the same phase. What is that? Are in the same phase. Same phase and it could be if you're taking the reactant as also liquid, your catalyst will be also in a liquid state. If you're taking reactant as your gas, your catalyst will be also as a gas medium. Like that. So when the reactants and the catalyst used are in the same phase, the process, remember the process, this word is important. The process is called as what? Homogeneous catalysis. Homogeneous catalysis. Please mark my words. We are talking about the reactants and the catalyst. If the used reactants and catalyst are in the same phase, the process is called as what? Homogeneous catalysis. Of course, now you can just guide me to define your heterogeneous catalysis. What it would be? When the reactants and the catalyst. What is that? When the reactants and catalyst are in different phase. Then what you can call it as a, so that process, the process is called as what? Remember, the process is called as heterogeneous catalysis. Is called as heterogeneous catalysis. Alva. So this way you can do it. If you ask me the example, so can we see this? Of course we have done it too. So first one, we can just check it out for oxidation of your sulfur dioxide. So basically it will be giving you as what? SO3. Of course we know what SO2 is a gas, O2 is a gas, SO3 is also a gas generally. But it is falling under the category of homogeneous catalysis. Why? What is the hint now we can have? Whatever the catalyst we are going to use, that catalyst phase and that of your reactant phase will be same. Remember, in order to carry out this reaction, we will be using nitric oxide, which is also a gas. This will be nitric oxide used as what? Your catalyst. And it follows in the homogeneous catalysis. Similarly, your methyl acetate, hydrolysis of your methyl acetate CH3 COOCH3, it will be in a liquid state, yes, plus water, which is also in a liquid state. So this will be giving you as what? Acetic acid CH3COH plus that of your CH3OH. So what is the hint? It is also falling under homogeneous catalysis, means our catalyst phase should be in which phase? Yes, it should be in liquid phase. So basically we are using over here as what? HCl. Remember, whenever they are in exam, they are asking you to write the examples. After writing the examples, the reactants and the catalyst, you have to also mention the phases, because the overall answer depends upon these phases. Merely just writing this much will not give you any marks. Please do remember, I am mentioning once again, whenever you are writing an example for homogeneous and heterogeneous catalysis, after writing the reaction, you have to mention the phases of each of the reactant and that of your catalyst. Very much important. Okay. Similarly, we can also see for hydrolysis of the sugar. I think in your lower classes you have seen this equation C12H22O11 in the presence of what? H2O, which is also a liquid. This is actually aqueous. Aqueous and it is also liquid itself. So here what you are using? H2SO4. Of course, this is also a liquid which is acting as a catalyst. So here you will be getting as what? C6H12O6 plus C6H12O6. What is this? Yes, one will be glucose, another will be fructose. One is having an aldehydic group, fructose is having a ketonic group. We will be seeing these things in your biomolecules. Now just for a while you remember, whenever a hydrolysis of the sucrose is taking place, it is taking place in the presence of your sulfuric acid. Since both your reactant and that of your catalyst are in the same phase, it is falling under the category of your homogeneous catalysis. And during the hydrolysis of your sucrose, you are getting as what? Glucose as the fructose. So both are having the same molecular formula but different functional group. Alva, they can be an example of what? Functional isomerism. Yeah. Now coming to our heterogeneous catalysis, which one we can see the major important thing we have seen? Haber's process, alva, N2 plus 3H2 in the presence of which catalyst? Iron catalyst. So here N2 is gas, H2 is gas, but iron is what? A solid, which gives you as what? 2NH3, which is once again a gas. Alva. Why it is said as an heterogeneous catalysis? Because the reactant used is in the gaseous phase and the catalyst used in the solid phase. Alva. Any similar examples? I would like to give one of the seen example. That is, if you take any vegetable oil, alva, vegetable oil tagondo hydrogenation ಮಾಡಿದ್ರೆ in the presence of which one? Nickel catalyst, you get as a vanaspati, or we can say as what? Vegetable ghee. Alva, vegetable ghee ಬರುತ್ತಿಲ್ಲ. Oil ಇದನ್ನ ghee ಮಾಡ್ತಿದ್ವಿ, ವನಸ್ಪತಿ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡ್ತೀವಿ? We are passing the hydrogen in the presence of your nickel catalyst. Vegetable oil ಯಾವುದು? Liquid. ಅಲ್ವಾ? So here nickel is what? Solid. So ಏನಾಗ್ತಾ ಉಂಟು ಇಲ್ಲಿ ಮೇಜರ್ ಆಗಿ? They are in what? Different phases. We can hear also gas. H2 is a gas over here. So liquid, gas, solid. So they are in different phases. So it also falls under the category of your heterogeneous catalysis. Once again I am mentioning, whenever, what is that? Whenever you are doing or writing the example for heterogeneous catalysis or homogeneous catalysis, that example should be also included with their respective phases. Similarly, this reaction we can also be carried out instead of using this oxygen, just by using the platinum metal. So again agutte 2SO2, which is actually a gas, whereas platinum is a solid, but the product you are getting as SO thrice itself, which is once again a gas. So with using your platinum catalyst also we can oxidize your sulfur dioxide, which falls under the heterogeneous catalysis. Yake? Because your SO2 is a gas whereas your platinum is a solid. An important process you have to remember. So of course we came to know as what? Catalyst means what? They are the chemical substances, or they are the substances which accelerate the rate of the reaction, remains chemically and quantitatively both. ಎಷ್ಟು ತಗೊಂಡಿರ್ತೀರಾ a quality ಮತ್ತು quantity that should remain unchanged after the reaction, and also it has to be regained at the end of the reaction. So process, so overall ಒಂದು reaction ನ catalyst ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಿದ್ದಾರೆ ಅಂದ್ರೆ ಆ ಒಂದು process ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? Catalysis. So basically there are two important types of the catalysis. One is called as a homogeneous catalysis, another is your heterogeneous catalysis. So in homogeneous, what we are saying? So homogeneous catalysis means when the reactants and the catalyst are in the same phase, the process is called as what? Homogeneous catalysis. Common example we have seen that of your hydrolysis of your methyl acetate, we could see that whatever the methyl acetate you have taken that is in the liquid state and used its catalyst, that is your HCl, which is also in the liquid state. So same phase, it falls under the homogeneous catalysis. Heterogeneous means what you can say, when the reactants and the catalyst, please do mark my words, reactants and the catalyst are in different phase. The process is called as what? Heterogeneous catalysis. A common example is your Haber's process, where we have, for the production of ammonia, you have taken your reactants which are in the gaseous phase, but the used catalyst is that in the solid state. So this is a major example for your heterogeneous catalysis. Once again I am repeating, whenever you are writing the examples for homogeneous and heterogeneous catalysis, you have to mention the respective phases. Okay. But now when the question arises that among the two catalysis, which is the most widely used or the most importantly used is, remember, it is your heterogeneous catalysis. It is having the wider application. If you are having a solid surface, it would be easy for the adsorption of the liquid or the gas to come and sit on it instead of choosing for liquid or a gas like that. Of course, solid is somewhat difficult. But when you are having this heterogeneous catalysis, if your catalyst is a solid and that of your reactants is a gas or a liquid, a wider application can be seen. So first of all, let us understand how this catalysis process is taking place. Of course, when we say that when you are using the catalyst, it is increasing the rate of the reaction. Then the question arises that what is happening on the surface of the catalyst. So let us now understand the mechanism of your heterogeneous catalysis. Remember, overall mechanism of your catalysis is divided into 5 steps. First step, what is that? Mark my words, it is your diffusion of reactant molecules on the surface of catalyst. First one, to diffusion of the reactant molecules on the surface of catalyst. First point. Second point, they are moving towards in the first point, whatever the reactants you have chosen, they are moving towards the surface of the catalyst. Then the next important is adsorption of reacting molecules. Adsorption of reacting molecules on the surface of catalyst. Next, third point, ಏನಾಯಿತು ಇಲ್ಲಿ ಫಸ್ಟ್ ಅಲ್ಲಿ ಏನಾದ್ರು ಡಿಫ್ಯೂಸ್ ಆಗ್ತಾ ಉಂಟು. ವಾಟ್ ಎವರ್ ದಿ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಅಂತ ಫಸ್ಟ್ ಡಿಫ್ಯೂಸ್ ಆಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಕ್ಯಾಟಲಿಸ್ಟ್ ಕಡೆಗೆ ಹೋಗ್ತಾ ಉಂಟು. ಸೆಕೆಂಡ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಏನಾಯ್ತು, ಹೋಗಿರೋ ರಿಯಾಕ್ಟೆಂಟ್ ಬಂದು ನಿಮ್ಮ ಸರ್ಫೇಸ್ ಆಫ್ ದಿ ಕ್ಯಾಟಲಿಸ್ಟ್ ಮೇಲೆ ಬಂದು ಕೂತು ಓನ್ಲಿ ಆನ್ ದಿ ಸರ್ಫೇಸ್. Third is important. As soon as the adsorption is taking place, the third step involves the chemical reaction between the reacting molecules. Yes. What does it do on the surface itself? On the surface of the catalyst. Remember, it to form an intermediate product. So this intermediate product is highly unstable. ಅಲ್ವಾ. ಏನು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಪ್ರಾಡಕ್ಟ್ ಅಂತ ಹೇಳ್ತಿದೀವಿ, ಫಸ್ಟ್ ಏನ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ದಟ್ ಇಸ್ ಹೈಲಿ ಅನ್ಸ್ಟೇಬಲ್ ಅಂಡ್ ಕೆನಾಟ್ ಬಿ ಎಕ್ಸ್ಟ್ರಾಕ್ಟೆಡ್ ಈಸಿಲಿ. Then what happens, this intermediate product breaks and then you will be getting your product. But first ಏನಾಗ್ತಾ ಉಂಟು, ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆದಾಗ ಆ ಸರ್ಫೇಸ್ ಮೇಲೆ ಒಂದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಥರ್ಡ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ. ಫೋರ್ತ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅನ್ನೋದು ಇಂಪಾರ್ಟೆಂಟ್ ನಮ್ಗೀಗ. ಸೊ ಈ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಪ್ರಾಡಕ್ಟ್ ಏನಾಗುತ್ತೆ, ಅಫ್ಕೋರ್ಸ್ ಇದು ಬ್ರೇಕ್ ಆಗಿ ನಿಮ್ಗೆ ಪ್ರಾಡಕ್ಟ್ ಕೊಡುತ್ತೆ. ಇದೇನಂತ ಹೇಳಿದ್ರೆ, ಟು ಫಾರ್ಮ್ ಎನ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಪ್ರಾಡಕ್ಟ್ ವಿಚ್ ಡಿಕಂಪೋಸ್ ಟು ಗಿವ್ ದಿ ಪ್ರಾಡಕ್ಟ್ ಅಂತ ಬರೆದ್ಬಿಡೋಣ, ನಿಮ್ಗೆ ಈಸಿ ಆಗುತ್ತೆ. ಡಿಕಂಪೋಸ್ ಟು ಗಿವ್ ಪ್ರಾಡಕ್ಟ್. ಈ ಥರ್ಡ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ನಮ್ಗೆ ಈಗ ಏನಾಯ್ತು, ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಯ್ತು. ಸೊ ಈ ಪ್ರಾಡಕ್ಟ್ ಏನಾಗುತ್ತೆ, ದಿಸ್ ಪ್ರಾಡಕ್ಟ್ ಹ್ಯಾಸ್ ನೋ ಅಫಿನಿಟಿ ಆನ್ ದಿ ಸರ್ಫೇಸ್ ಆಫ್ ದಿ catalyst. No affinity on the surface of catalyst. That means whatever the product has been formed, that will not try to remain on the surface itself, because whatever the bonding is there between the product and that of your catalyst surface is very weak. So what it tries to do, yes, so therefore desorption takes place. Alva. So ಏನಾಗುತ್ತೆ, desorption takes place, or desorption of product away from the surface of the catalyst. Desorption of the product from the surface of the catalyst. Alva. So as soon as the product has been formed, ಏನಾಗುತ್ತೆ ಈಗ, desorption. That is the reason I mentioned in my earlier class. What do you mean by desorption anta? So desorption of the product from the surface of your catalyst. And the last important point is the diffusion. Diffusion of product. Yes, away from the catalyst. So these are the important 5 things what is happening on the surface of the catalyst. That is also in heterogeneous catalysis. Please do remember. First is what happening, the reacting molecules are coming towards the surface of the catalyst, which is called as what, diffusion. As soon as it comes to the surface, what happens, by the residual force on the surface of your catalyst, it absorbs the reacting molecules. Since we have got a medium for the reacting molecules to come and sit and react, the third will be the chemical reaction takes place to form what, an intermediate product. Since the formed intermediate product is highly unstable, it will decompose to give you the product. So this product, what will be having, it will undergo desorption because it is having a less affinity on that of your surface of the catalyst. Desorption and whatever the bond is there, that is just broken off. Once it has been broken off, what happens then, once again the product goes away from the catalyst. So these are the important 5 terms. For example, if I just show them in schematic diagram, let me show you in this way. Let us consider this is your surface of the catalyst. Okay, whatever we are in surface. So now you are using your A plus B. 2 reactants are there. So now first ಏನಾಗುತ್ತೆ, this reactants are diffusing, means they are moving towards the surface of the catalyst. So in the second step alva, adsorption takes place. ಯಾವ ತರ adsorption ಆಗುತ್ತೆ ನೋಡೋಣ, like this. If I take, here will be your A, here will be your B, and like this. So ಏನಾಯ್ತು ಈಗ, they have come and sit on the surface. So as soon as they have sit, what happens, now this forms a reaction ಆಗುತ್ತೆ, ಒಂದು intermediate product form ಆಗುತ್ತೆ. ಯಾವ ತರ product ಅಂತ ನೋಡೋಣವಾ. So basically like this. ಅಲ್ವಾ, ಈ A ಮತ್ತೆ B ಮಧ್ಯದಲ್ಲಿ ಕೂಡ ಒಂದು ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಒಂದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಪ್ರಾಡಕ್ಟ್ ಅಲ್ವಾ. ಇಲ್ಲಿ ನೋಡಿ, ಆ ಬಾಂಡ್ ಇಲ್ಲ, ಬಂದು ಕೂತಿದೆ ಮಾತ್ರ. ಸೊ ಆ ಬಾಂಡ್ ನಾವ್ ಯಾವ್ದು ತೋರಿಸಿ, ಸರ್ಫೇಸ್ ಆಫ್ ದಿ catalyst. ಈಗ ಒಂದು ಬಾಂಡ್ ಫಾರ್ಮ್, ಇದು ಒಂದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗಿದೆ ಅಂತ ಹೇಗೆ ತೋರಿಸ್ತಾ ಉಂಟು, A has been bonded with B. So now what happens, whatever this formed product is there is an intermediate product, will decompose to give you the final product, and that product will be what will be having, it will be having the lesser affinity. So final step ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ನಿಮ್ಮ ಡಿಸಾರ್ಪ್ಷನ್ ಆಗಿ ಡಿಫ್ಯೂಷನ್ ಆಗಿ ಏನಾಗುತ್ತೆ, ನಿಮಗೆ catalyst ನಿಮಗೆ ವಾಪಸ್ ಸಿಗುತ್ತೆ. catalyst ಏನಾಗುತ್ತೆ, ವಾಪಸ್ ಸಿಕ್ಬಿಡುತ್ತೆ, ಪ್ಲಸ್ ನಿಮಗೆ A B ಅನ್ನೋ ಒಂದು ಪ್ರಾಡಕ್ಟ್ you will be getting. This is the overall process. So So first is the diffusion of your reactants, then is your adsorption of your reacting molecules, then the chemical reaction to give you the intermediate product, which decomposes to give you the final product, and that product undergoes desorption, finally will be your diffusion. So by this way we will be getting your product, and that of your catalyst remains unchanged, and also quantitatively and qualitatively it is extracted back at the end of the reaction. So this is the overall mechanism which is taking place that are your heterogeneous catalysis. Very much important. So whenever we are using a catalyst surface, this is the overall mechanism which takes, which gives us the part that how does a chemical reaction takes place and how does it decreases the magnitude of activation energy. Is that okay? So next we are going to see certain important concepts what we are going to use again and again whenever we are using a catalyst in our concept, yeah, and that is by the name called as that of your activity, selectivity. What do you mean by promoters? What do you mean by poisons? That is, for example, if I am going to write N2 plus 3H2, of course when I was using my Haber's process I was writing iron as a catalyst, but also I mentioned as I will be using this molybdenum as a promoter. Of course, we use certain things to give O2NH3. So now this question arises, what is this promoter? In certain cases, we also use the word as catalyst poisons. We'll be seeing what are those means. Okay. As we mentioned, there are also certain concepts in the catalyst for which one has to know whenever you are using the term known as catalyst. So of course I have given you the example as what in the Haber's process, that whenever we are doing the manufacture of ammonia, of course we are using what? Iron catalyst along with a molybdenum promoter. So what do you mean by this molybdenum promoters? Remember, promoters means which enhances, or in simple words I can just say that which increases the activity of catalyst. What is that? Activity of catalyst. Here you have to make a word note that I am using the word as what? Activity. It also has a physical significance under the concept of your catalyst, which we are going to see in this video itself. So what are promoters? Which enhances the or increases the activity of the catalyst. Similarly, in certain cases, we are also using certain catalyst poisons. Remember, what does it do? If promoters are increasing, this catalyst poisons decreases the activity of catalyst. Decreases the activity of catalyst. Of course, now you can ask me, of course, sir, we saw the promoters, that example is your molybdenum. Can I give an example for catalyst poison? Of course, we can give you. So for example, we can take in the production of SO3. What is that? In the production of SO3 from the contact process. That is manufacture of your sulfuric acid. Now in one step we are manufacturing or we are preparing SO3 from SO2 and O2. SO2 and O2. So at that particular time, what I would be doing is I will introduce some, or in certain cases they may also get introduced, or in certain cases we can introduce in order to retard the reaction as CO and CO2. So when the CO and CO2 is present along with this SO2 and O2 during the production of your SO3, the yield of the SO3 decreases. So this can act as what? Catalyst poisons. There is a reason we are saying that catalyst poison decreases the activity of the catalyst. Again I am mentioning activity. Now we have to understand the important concept in your catalyst called as activity. Of course, what we have seen, and a major important thing, an important concept called as selectivity. A breathtaking concept, very much interesting. So what is the meaning by, what do you mean by activity? Let us first understand. Remember, it is the ability of the catalyst. What is that? It is the ability of the catalyst, yes, to increase the rate of the reaction. To increase the rate of the reaction. Of course, was what we have studied earlier. So activity means what? It is the ability of the catalyst to increase the rate of the reaction. That is to what? To increase the velocity of the reaction or speed of your reaction, we can say. Alva. Of course, instead of saying speed, I should mention it as velocity itself. Yeah. But now when the question arises, of course, whatever we have seen in our day-to-day life, that is, for example, 2H2 plus O2, it is taking place in the presence of your platinum. H2 is a gas, PT is a solid, which gives you what? 2H2O. It's a hydrogen fuel. Of course, you will be seeing once again about these concepts in your electrochemical series. So an important process. Whatever in your space rockets it is taking place, it mainly depends whatever the electricity requirements is required in your space rockets. It is mainly done by that of your hydrogen fuel cells. And in that hydrogen fuel cells, we will be mainly using this one as our reactants. Of course, we will be seeing in the chapter of your electrochemistry. But the major thing is we are using over here as platinum catalyst. What it is doing, the production of the rate of the reaction will be greater. So this type is called as what? A concept of activity. So it is the ability of a catalyst to increase the rate of the chemical reaction. Okay, in chemisorption, basically we can say in chemisorption. Then what do you mean by this selectivity? See, the name itself, you just split the words. Selectivity, it is selecting. Alva, that means what? It is the ability of the catalyst. It is also an ability of the catalyst to do what? To direct the reaction. To direct the reaction to yield a particular product. To yield a particular product. This is called as what? Selectivity. It is selecting something. It has to give that one itself. We are very much selective. So that is the reason what we are saying. It is also an ability of the catalyst to direct the reaction. That is, it is making the reaction to go in that step itself. So when it is following in that step itself, what happens? We will be getting a particular product. Let us go with an example. For example, if I am going to choose carbon monoxide in the presence of your hydrogen. Yes. So when I am using my nickel catalyst for this reaction, of course your carbon monoxide is a gas, H2 is a gas, nickel is a gas. The product what I am getting is my methane. This is a gas plus that of your H2. When I am using the same reactant in the presence of your, we can say, copper catalyst. This is your solid, this is your gas, this is also your gas. So here what is happening, I am getting my methanol, formaldehyde, which is also a gas in this case. Yes. So you could just notify over here. So in the first case, when I choose my nickel as the catalyst, I got the product as what? Methane, the major product. So in the second case, when the reactants are same in both the cases, but when I change the catalyst to copper, I am getting as what? Formaldehyde. So what it is doing, it is called as selectivity. What the selectivity of the catalyst is doing? It is directing the reaction to yield a particular product. Similarly, one more example is there. I hope it is given in your notes also. CO plus H2 in the presence of copper and that of your zinc chromic oxide. That you know. Copper or zinc chromic oxide. So this is giving you what? Methanol. CH3OH. Of course, this is your gas, this is your solids. You can just see in all the three cases the reactants are same, but when we are changing the catalyst, when you are changing the catalyst, a particular product is formed. That is the ability of the catalyst to direct a reaction to yield a particular product. Very much important concept about your activity and selectivity. So whenever they have been asked to write an example for selectivity, just don't write one example. It's a common sense thing. You have to write two examples to show what, when you are using the nickel catalyst, you are getting one product. But when you are using for the same reactant and another catalyst, you will be getting a different product. So whenever they have been asking you to write the example for selectivity, you have to mention what? Two examples. But in case of the activity, one example is enough. You have to see how many examples they have asked. If they have said give 2 examples, you have to give 2 examples for activity also. But in case if they have said give an example for selectivity, you have to write the 2 examples to show them that when we are changing the catalyst, you will be getting a different product, an important thing. So activity means what? It is the ability of a catalyst to increase the rate of the reaction by decreasing the magnitude of the energy. That is the reason. Okay, we know that. But when you are choosing for selectivity, remember, it is the ability of the catalyst, yes, to direct a reaction to yield a particular product. This concept is very much important. Yeah. Why we are mentioning this? Of course, the one of the major important thing which we are seeing whenever the term or the concept of catalyst comes to our mind is our zeolites. Alva. So what I mean by zeolites? So whenever we are talking about zeolites, mainly they are falling under the category called as what? Shape, yes, selective. Shape, selective catalysis. Alva. So zeolite is one of the best example for your shape selective catalysis. Why we are saying it? First of all, we have to understand what do you mean by shape selective catalysis. Remember, whenever a catalytic reaction, what is that? Whenever a catalytic reaction depends on first pore structure of the catalyst. Pore structure, that means holes we can say, or the small pores will be there on the catalyst surface or the active centers. If I have written over here when I was mentioning my mechanism, you can just see these holes. So these are actually called as an active centers for the catalyst, where it is facilitating for your reactants to come and sit. That is called as what? Pores. So whenever you are using such shape selective catalysis, that catalytic process will depend on what? Pore structure of the catalyst, first important thing. And then it also depends, the second part, size of what? Of both product, sorry, first I should mention as well, of both reactant and product. Both reactant and product molecules. Both reactant and product molecules. So first and the foremost thing, whenever we are talking about a shape selective catalysis, remember that catalytic reaction depends upon what factors? One is the pore structure on the catalyst, and the second, size of the both reactants and the product. You can only tally them. If it is matching with that of your reactants and the product, that is size of, if the pore size is matching with the size of the reactants and the product, of course the catalyst will be very much useful to us. Alva. That is the reason we are saying it depends upon both of these things. Why we are saying zeolite is an example for this? Because when we see the zeolites, remember, they are having a honeycomb-like structure. Honeycomb-like structure. Honeybee hive nodaga, honey tegidaga, they will be having how? Like somewhat hexagonal shaped structures will be there. We have seen, if you are mentioning it, like this it will be continuing. Alva. So like this, it is also having such structures. So idara ಒಂದು structures na build ಮಾಡಿ ಈ zeolites ನಾವು manufacture ಮಾಡಿರ್ತೀವಿ. So that is the reason what we are saying that zeolites are the good shape selective catalysis due to their honeycomb-like structure. But when you ask, what do you mean by this zeolites? Basically, of course, we have seen in our first PUC also. Remember, they are the microporous. Microporous and artha eno, whatever the pore size is there, that is in the range of 10 to the power of minus 6 micro, not plus 6. Plus 6 means mega. Minus 6. Okay, they are the microporous alumina silicates. What is this? They are the microporous. Remember, very much important. Microporous alumina silicates. Alumina silicates. What will be having them actually? ALOSI. Very much important concept. ALOSI framework ಅಲ್ಲಿ ಈ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಅವು ಬಿಲ್ಡ್ ಆಗಿರ್ತವೆ. Okay, so what are zeolites? They are the microporous alumina silicates with Al bond O bond Si framework. They are one of the best shape selective catalysts. What is the reason? Because of their honeycomb-like structure. And majorly, whatever the reaction it takes place, alva, since it is a shape selective catalysis, The reaction depends upon what factors? Pore structure of your zeolite and also the size of your both reactant and the product molecules. Of course, in many classes we have also mentioned, what was that? The major example for zeolite is that of what? ZSM5. Alva, ZSM5. What is the full form of this ZSM5? Zeolite. Z stands for zeolite. Next, what is that? S. What does S means over there? Sieve. S-I-E-V-E. Zeolite sieve of molecular. M stands for your molecular porosity or porosity. Zeolite sieve of molecular porosity 5. ZSM stands full form. Zeolite sieve of molecular porosity 5. ಇಲ್ಲಿ ಮೇಜರ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ to convert for what? Alcohols to gasoline. Alva, alcohols to gasoline. That is your petroleum products with other hydrocarbons. ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? Gasoline. So here we are using as what? ZSM5 in the process of your dehydration ಆಗುತ್ತೆ. Dehydration ಆದಾಗ ಏನಾಗುತ್ತೆ? Alcohols ಇದ್ದಿದ್ದು gasoline ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. So in petroleum industry ಈ ಒಂದು ರಿಯಾಕ್ಷನ್ ಕ್ಯಾರಿ ಔಟ್ ಮಾಡಬೇಕಂದ್ರೆ we are using a shape selective catalysis, that is your ZSM5, which means what? Zeolite sieve of molecular porosity. So this is the major thing we have to understand with respect to the catalyst. That what do you mean by catalyst? First important thing. Then what are the two types of your catalysis process? Homogeneous and heterogeneous. How can we classify them as a homogeneous and a heterogeneous? Then what is the mechanism of the catalyst surface? Most important thing is called as that of your selectivity and that of your activity. Of course, till now we were knowing the activity part of the catalyst, but in this chapter we also came to know about the selectivity of the catalyst. That is, how does when you are using a particular catalyst, instead of though you are having the same reactants, by using the different catalyst we can get the different products. Very much important. Okay, and while writing the examples you have to mention in selectivity 2 examples you have to mention to show that how they are varying the product. Alva. And in that of your heterogeneous and homogeneous you have to mention the phases of your reactant and the catalyst. Then we also saw one of the best wider use of the catalyst phenomenon or the type, you can say, that is your shape selective catalysis. Why we are saying it as a shape selective catalysis? Because whatever the catalysis process we are depending, it depends upon the pore size and also about the size of the reactant and the product. And the major example is that of your zeolites. Why zeolites are called as that of your shape selective catalyst? Because of their honeycomb like structures. What are zeolites? They are the microporous alumina silicates with AlOSi framework. Very much important. An important example for zeolite is that of your zeolite sieve of molecular porosity, POROSITY 5. Or in simple words we say as all the letters are caps. ZSM, all are caps, -5. Where it has been used to convert your alcohols to gasoline by the process of your dehydration in your petroleum industries. Is that clear? So these were the catalyst part which we have seen in our day-to-day life. But now it will be a very astonishing thing to know that we are also going to study the catalyst phenomenon in your body. Alva, the catalyst phenomenon in our body. That how does this catalyst is playing a role in our body under the heading called as enzyme catalysis. Enzyme catalysis. So we have to see that how does the enzymes are playing as a role of catalyst and what are the important characteristics when enzymes are acting as a catalyst. Alva, that is very much important. Can each and every enzyme we can act as a catalyst for each and every reaction is the first important question. Alva, because in our body, of course, many complex reactions are taking place. Question arises that can each and every enzyme can act as a catalyst for any reactions? That is the first question. Second most important thing, whether that enzyme catalyst can operate in any temperature. Alva, very much important. So these are the certain things we are going to study under the concept called as enzyme catalysis in our next video.